That was exciting. I don't think I've ever been introduced by a jingle before, but there we go. Good evening, everyone. I'm Carl Robinson, CEO and co-founder of Logicata and one of the co-founders of the AWS Brighton user group. Welcome to meetup number 10. We're in double figures now, not quite a teenager yet, but we are in double figures of the AWS Brighton user group. So got a couple of great talks lined up for you tonight. So I'll just quickly run through today's agenda. Introduction, that's me. And maybe Cam will say something from Silicon Brighton, and maybe our hosts will say something about our venue as well. Once we've done the intros, we've got our first talk from Nelson Alphonso, who's going to talk about infrastructure anomaly detection with agents. Managed to get that talk title without AI in it, but I'm sure it's going to include a lot of AI, which of course is very topical at the moment, but well done for not including it in the title. Followed by Nelson's talk about anomaly detection with agents. We're then going to go on and hear from Paul Stack from System Initiative, all about automating AWS integration with Amazon Cloud Control API at System Initiative, which is where Paul works, and I'm sure he'll tell you more about that when he does his talk. And then we should be able to wrap up by about 7:50 to 8 o'clock with some closing remarks. There may be some pizza left, I'm not sure. There's definitely some beers left. We might also go to the pub if anybody doesn't have to rush off home. So this event is being recorded. If you don't want to be included in photographs or video content, I don't get the option, unfortunately, but please speak to the organizers. That's me, John, Anita, or Cam from Silicon Brighton. So I've already said who I am, but just a little bit more about me. I'm an AWS community builder in the cloud operations category for the third consecutive year now. It's actually my fourth year, but I got kicked out after year one, reapplied, got back in again, and they've renewed me for the third time. I'm also CEO and co-founder of Logicata, who are sponsoring the beer and pizzas and the keyring bottle openers over there on the table this evening, and the cookies. Yeah, although AWS paid for the cookies actually, because I put a fund request in and got them to pay for the cookies. So thank you AWS for paying for the cookies. So Logicata, we're an AWS advanced partner. We provide managed services and consulting for AWS small and medium business customers. So that's me. John, are you coming up? Or do you want to... Yeah.
Hi, I'm John. I love a microphone, so I don't let him do this for me. I'm also a community builder in the serverless category, which is a real category. And I'm going to ride that gravy train as long as I can, because cloud operations is a catch-all and serverless means I talk about serverless stuff, which is much more interesting. I am lead cloud engineer at Logicata, which I've no idea what that means in practice. I do what he tells me and then complain about it afterwards. That's about the size of it. I don't have a clicker. The next slide you can skip because it's got Steve's face on it. I would normally give it to Steve at this point, who is... I've called him InfoSec Ninja, but I think he's retired now and he's off sick today as well. So no, none of that's true. So I'm going to leave the microphone to Anita instead.
I'm Anita, work at Lightspeed Systems, and I'm here because I found people that I can talk to about my work in Brighton, like in person, which is awesome. And the work is I look after, I don't know, I think it's like 60 plus AWS accounts now that we have at Lightspeed. Everything is in AWS, and I love it. So, Nelson. Oh,
no, not yet. No, let's thank you, Anita. So this is our link tree, which will just take you through to our meetup group, I think. But obviously, you're all here already. But if you're watching online and you'd like to attend in person, scan the link tree, join our meetup group. You'll hear about future meetups. We do run quarterly at the moment. So our next meetup is probably got a slide on that later in the deck, but it's in October. So I've already mentioned Logicata. FreedomWorks, though, I have not mentioned. So do you want to say a little bit about FreedomWorks? So we are hosted tonight in the FreedomWorks co-working space. So thank you very much for your generous sponsorship. Tell us a little bit about FreedomWorks.
Great, thank you so much. Yeah, so we're FreedomWorks, and my name's Maya. I think I've met a few of you now, but I'm the community manager here. So I look after the space and the members that we have. We've got 10 spaces under the name of FreedomWorks, but we've also now got Platform 9 as well, which is also popular co-working space in Brighton too. So we've now got those two kind of offerings. We offer meeting rooms, hot desks, dedicated desks, event space, such as for this. private offices and virtual offices as well. Yeah, the goal is to really get to the moon and have that all on the moon. So part of my job as well is to really try and build a community. So this is why we love doing events such as this one. And we've worked with other community groups. So we put on shared lunches. So next week we've got our August one, well, end of July, but it's going to celebrate Pride. Obviously, Pride is happening next weekend, so that's a big event in the city. And yeah, we do free beer Fridays, so that's always very popular. And yeah, that's pretty much about us. But if anyone's interested, we do have a flyer there, and also can come and speak to me. Thank you.
Thanks, Maya.
No worries.
Thank you very much. And then I think, Cam, do you want to say something about Silicon Brighton? Of course, yeah.
The slides are here, aren't they? Sweet, thank you. Oh, and a clicker. Thank you very much. Hey everyone, my name's Cam. I work for Silicon Brighton in the community and events department, or executive, I think so. Company of free people, and the department is me. But yeah, so we are the hosts of we're the hosts of Brighton Hosts Digital Tech Sector. We put on loads of meetups just like this. We've actually started putting on our own conference as well. I think we can talk about it quite casually like that now. No, it was 3 or 4 weeks ago. It was wicked. It was, like, as we said, the meetup for meetups. Everyone came down. Everyone had a great community fun time. So yeah, if you want to host any meetups, come chat to me, or you want to do anything more community based in other areas, that'd be brilliant. Here are some of the other meetups that we support. They're a little bit small, but I can see we've actually got some other meetup organizers in the room as well. So it's just a true community effort. Everyone comes to each other's events, and like there's always going to be another crossover community that you can join in. We are also supported by loads of businesses, as we're a not-for-profit, but all of the support and sponsorship allows us to come to events just like this, live stream it, and just generally give advice and help connect the dots in the business communities. We have James Chase as one of our sponsors, who are a brilliant company, as well as Plus Accounting, More Law, and recently Alirity. We've got also a Linktree, which has got access to our Slack community, which is brilliant for everything that you could need to communicate with each other in a business community could need, as well as all of our other meetups and socials as well. So check that out if you haven't already. Also, speaking of the other meetups, we have the Earl conference coming up, which we're supporting in the AV tech world. So if you enjoyed Evolve or felt that the AV there was good, that's your thumbs up of approval. Earl's a conference if you're an R or Python programming working in the R or Python programming language. So definitely check that out. There's a few. Earl stands for. I don't know what Earl stands for. Well, enterprise applications of the R brackets and Python language. I'll say it on the stream as well. But yeah, no, they were thinking about Perl, but they decided not to. Yeah, but yeah, I think, as John says, that is definitely a thing. But I've sat on this slide for a wonderful amount of time. So thank you very much, guys, for having me come up and chat.
Thank you very much, Cameron. So that's the introductions over with. So on to the main content for this evening. As I mentioned, Nelson Alphonso is going to run us through his talk about infrastructure anomaly detection with agents. So Nelson, please come and take the stage.
All right, thank you so much. Thank you so much, everyone. Yeah, so my name is Nelson. I'm a AWS community builder, and at the same time, I work as a senior machine learning infrastructure engineer. I know the title is a bit long, but yeah. So one of the main challenges, I think, that when you're developing an infrastructure, I think what comes in is that the building part is really easy, but maintaining it and monitoring and having observability into the system is one of the most trickiest part, because first thing first, when you come in, you're not the one who has worked on the infrastructure before, right? So there's going to be a lot of things that everyone knows that nobody knows what's there inside. And to gain observability into that would mean that you spending most of your time trying to go into every nook and corner of the infrastructure to see where something is and what is making changes to what, basically. And that is one of the main issues that most of the time I have faced in my organization. And the solution that we came up with is that first thing first, we would see like what happens with delaying any detections, right? Like on average, the time that takes to detect any of data leakage or any kind of issues, or also like being compromised. On an average, on an industry studies, it's 287 days later on average, where you come to know that okay, something has gone wrong, something has been leaked. And one of the most yeah, that's all right. uh,
No, I've put Netflix on.
Oh.
I was trying to get rid of the mute logo off the screen. And, what do I need to? Yeah, use the Swift one. Yeah.
We've still got it on the stream.
HDMI. Yeah. Sorry about that, guys. Yeah, there we go. Yay!
All right.
And the mute symbol's gone.
Okay.
Which is what I was trying.
All right. So
Take that away.
so yeah, as I was saying that now that everyone knows that LLM agents and all of these things have been introduced into workplaces, monitoring humans was one aspect of the problem, right? Now you're introducing another autonomous technology that can make decisions. And I think that everyone is maybe quite familiar in this week with Replit, where it completely erased the production database. How do you prevent that as well, right? As something I was not prepared for, but I'm just putting it in there. And also that another thing that happens is that the response time to mitigate such issues is on average quite long as well, because there's an issue, but how do you rectify it, how do you mitigate it? So there are different technologies in AWS that can help us mitigate these anomaly detection and give us more visibility into what's going on and what changes are being made into the resources. But for this solution that I came up with, I have kept EventBridge in the center of everything, and agent would be the one who would be as a security manager for us. And of course, what is the benefit of this integrated approach, we will be seeing in the following slide. So this is how the architecture is. So basically, your services like Lambda, ECS, EC2, even SageMaker as well, they get recorded in different services. I think that everyone is familiar with CloudTrail out here, where every API call, every IAM changes that are being made is being recorded in CloudTrail. But there's also another service. I'm not sure how many of you are familiar with AWS config service. All right, so everyone is familiar with it. So basically, everyone knows then that AWS config is basically a service that acts as a recorder for your inventory and your instances, basically. So there's any change, any IMA role that has been changed on your EC2 instance, or even the instance size that has been changed, or anything that takes place gets recorded in config recorder. But now the thing is that you have so much data, so much information. What do you do with it? This also adds another complexity to your cognitive. Um, it basically causes a cognitive overload, right? Because now instead of you going inside and seeing, you have this data somewhere, but how do you interpret it, or how do you read this data, right? And that becomes complicated, and that is where I introduced an evaluation agent. That's basically a Lambda function that speaks to Bedrock. So whenever there's any information that comes in from config or from CloudTrail, it goes through EventBridge. Now, why did I put EventBridge out there? Is that I wanted to filter out certain certain events that I don't want. Basically noise, right? Like someone is reading a file, or someone is updating an IMM role, which they can do, right? If as long as it's not certain IMA roles. And the EventBridge rule filters out these things for me, and then it feeds this data into into an agent that is deployed on Lambda, and the LLM agent is on Bedrock, basically. And whenever there's any communication that happens, it sends out an email to us, which it redeems, or it identifies as potentially dangerous. And then when it comes to us as an email, in the email we can speak to it basically and say that, okay, yes, just make the remediation and do a thing is that just go and update this, and we send the email back. And once because this is all in a step function, the step function waits for an approval that comes in from the email whenever there's a reply basically, or SMS, whichever technology. It depends on who we have subscribed on the SNS out there. And then once we give this remediation in the email, there's another security agent that goes on and acts on these information, whether it is to run some SSM automation runbook, or it has access to different MCP servers that we have implemented, and that it can only specifically make certain changes to the system. Else, if it's not able to remediate it, it would just send us an email back that, if the thing has been successful or it has not been successful, and then someone else can go in. Also in the email, we can also tell it that, what, this is a save action. So, there's nothing else you can do. And then what it does is that, because it's connected with a database that we have, it goes in and says that, whenever in the future, if there's an action that is of the same of the same statement, just do not act on it and just ignore it basically. And that is how we have been able to utilize MCPs and agents in our security workflow, giving us full control over the changes that it makes, because I see that it's more of a addictive change than it's a destructive change, right? It's not going to go in and be like, what, somebody created a database, let's go and delete the database. That's not going to happen. And even if it tries to do that, we get an email and we can just say that, this is a safe action basically, and it can learn on that. And yeah, what happens with this is that it gives us a real-time monitoring. It has an event-driven architecture, gives us the violation detection, and then there is an auto remediation, and we have audit trails as well, right? Whatever the agent is doing, we have an audit trail in CloudTrail and in CloudWatch as well, right? And then we also make sure that there's a compliance validation. If we said no, next time just don't go and try to make changes to it basically. And yeah, um, so our Lambda security agent is a serverless solution for detecting and remediating security violation through integration with Bedrock. Yeah.
How does it filter out your intended changes? Is there a mechanism to filter that out? Maybe I would have missed it.
So what happens is that as soon as there's a violation that comes in from CloudTrail or config, it goes into EventBridge, and if there's a rule that filters it out, it doesn't go forward. But if there's a rule that allows it to go through, it would then go to the evaluation agent, and the evaluation agent would then try to look into the information and then send us an email. And once we receive the email, it will tell us everything about it, that this is the resources, this is the IAM security that being changed, etc., etc. What action do you want me to take basically?
It's not automatically doing it.
No, it's not doing it right now. There's a middleman. It comes to us, we can look at the information, be like, okay, you know what, go ahead, you can remediate it and remove this, and the service that's doing it even disable that service as well. So then when it receives this information, there's a security agent that would go in and act on all the remediation that we said. And at the same time, if we said it, tell it no, ignore it, it would just ignore it basically then. And it would record this in DynamoDB, and then whenever there's another action of the same nature, it would not act on it basically. So that's that. And yeah, the evaluation agent is also um, a Lambda function, and it uses Bedrock, and also make sure to choose the most appropriate SSM remediation runbook that we have inside, that is there by default, and some of them we created by ourselves. And if there is something that is not in the remediation runbook, then there's an MCP server that acts on that command that we have sent basically. And some common anomaly scenarios we have, like excessive invocation rate. Someone is trying to DDoS on our system or something, we can go, the agent would send us an email that, there's a very unusual high number of invocation, what do you want us to do? we can just say just throttle the Lambda function or just disable it basically. Or maybe we can even tell it that, you know what, whatever IP address it's coming from, just block it basically through the email, and it would go in and then make changes to our VPC, the route table, or to the network ACL, and it would just do it for us basically.
So you're replying to the email.
Email, yes.
Yeah. Sorry. So the question was, you're replying to the email that the automation is sending you.
Yeah.
And the model is then interpreting your instructions and
yes, and making
implementing
appropriate
them
changes.
automatically.
Yes,
Yeah.
that's correct. Yeah. So we just tell it like, you know what, just just blacklist this IP address, and it would do that for us basically. High error rate. There's maybe some faulty payload coming in. It would give it to you in the email address. You can maybe tell it like, you know what, whatever sources is it coming from, just disable it for now, or just maybe, have, whatever is this message that's coming in, and we don't have any record of storing it. You know what, just put this payload somewhere else, maybe in an S3 bucket, basically, or in CloudWatch, which it has access to already. And code that is directly updated through console. If your Lambda function is being updated by a developer, and like, how do you know about that? So even through compliance, to config and CloudTrail, you can get that information. And then of course the LLM agent will tell you basically that someone has directly uploaded the code through console. EC2, unusual login attempts, unexpected open ports or security group changes, and CPU utilization spike. Some of the observability that you can do with the LLM agent, basically, it can help you detect this as well, depending on how you set up the event rules in EventBridge, basically. And some of the implementation best practices, of course, and introducing a technology that is just been so recent, and there are a few things that we can do to make sure that the LLM agent doesn't go and deleting stuff, right? So you make sure that you have appropriate IAM policies attached to your Lambda functions. Make sure that the event bridge is in a way handling and not getting throttled with all the requests that is coming in, and also have a LLM evaluation design. I think that the prompt that you would add in the Lambda function would need to be should be secure in design, and also at the same time be very explicit with the commands that it should not do, basically. And yeah, that's about it. Any questions?
Thank you. So how can we use it today? Is this something that we have to pay you a lot of money for? Is this open source? Is it part of?
Well, that's a really good question. I was actually, it's open source. I have the source code with me. I wanted to present a demo out here, but I did not do it basically because we were using the community's laptop. But yeah, I would be open sourcing it in a few weeks, because of course, I'll be honest with you, I initially wipe coded it. Because of course I cannot use companies' data, right? So I had to wipe code it, and of course my own personal account was in the sandbox environment, so the email replies don't work or the SMS replies don't work because I need to request for that. So once that's all finalized, I will definitely put it out there. And yeah, of course you can add me on LinkedIn and wait for my next post, I guess.
Great, excellent, thank you.
No worries.
Thank you. So how would the system work if you had like multiple errors popping up at the same time? Say you've got one for a high amount of concurrent users on your Lambda and another one saying, yeah, you've also got unauthorized access in EC2. Is it all coming through the same message? Like, how can the system tell apart that, well, your response to one versus the other? Like, yeah, what would you do if lots of bad things happen at the same time? And yeah, how can it tell which one's which?
We have, as soon as the evaluation agent gets a message, it puts it into DynamoDB, because that's where it is, where we put the information that it has the user replied or not to the message. And because of course the messages are coming in, when it tries to add it to the DynamoDB, it sees that, okay, this is the same event that has taken place before, right? And then it would, like, not create user fatigue by sending them emails over emails over emails about everything. So that's there. And of course, like there are certain things that not every company would like it, right? It would be in a way that you want to only make sure that, for example, lambda errors, I want to be notified about that. You just go in EventBridge, in the event rule, you can just put it out there. Or also you can, keep your EventBridge rule open, and then at the LLM level, you can be like, you know what, whenever you get any errors related to lambda, don't send it to me, basically, and then it would remember that and put it into DynamoDB, basically. But yeah, if from a cost aspect, being that lambda function being triggered every single time, if that's a concern, then yes, of course, you would go in and maybe you want to put an SQS at the back of it or not, and make sure that there's deduplications happening on that level.
I'll give it to you in a minute. I was just going to follow up because I thought the question was more about concurrency rather than repeats. So you've got lots of different signals coming at the same time. How does the system handle that?
Yeah, then that for concurrency, I think that you would obviously put an SQS at the back. For us, we have taken, we did some risk assessment and seen that if we would get the concurrency higher or not, but for events like lambda errors, we have not opened it, basically. So for us, it's kind of safe. Because of course, lambda errors is something that you can even have a CloudWatch alarm for that. So you don't need to evaluate it through the lambda to the lambda agent, basically. So yeah.
So how frequently do you see those false positive alerts being sent to you? Like, has it been?
So on a monthly basis, I would say that we do get about 1 to 2 errors, and that agent tells us about it. Usually, it's the developer's mistake or something, or someone is just making several fail attempts because they forgot their password. But like in a real world scenario, when I initially deployed it, it was about 10 to 20 alerts just in the next few hours that came in because of misconfiguration at different places. But after that, it normalized, and 1 to 2, maximum 5 maybe in a month, but not more than that.
And have you ever seen that there were actual anomalies in your system, but this solution wasn't able to recognize those, maybe the misconfigurations?
I would say yes, but that was more on our end that we initially did not allow many of the rules in EventBridge to come to us. It was just suppressing all of those and not sending it to us. But then slowly, gradually, when we started adding more and more services to allow it, basically, that is when we started seeing that okay, there's a spike in the report that was coming in from the agent. Basically, sometimes it was 5. We add another service. There's another 15 alerts coming in. But then slowly, gradually, solving all of those errors and making it, calming it down. So it depends on a case to case basis. Now tomorrow, if there's another service that's going to be added, then of course I'm pretty sure that there's going to be another alerts coming in. Most of them are true positive, some of them are false positive, basically, because the LLM is not able to actually categorize the severity of the error, basically.
Sure, thank you.
No worries.
So a system like this, I immediately think of extensibility. I can see dollar signs, pound signs in my eyes.
Yeah, absolutely.
Like for sure, like absolutely. When we all get these dreaded emails from Amazon every month about scheduled maintenance and like replacement instances and things like that. Could this type of system be designed to work with that, to be able to remediate the action before it happens, rather than just let an Amazon actually defer it? So like, for example, if there is a scheduled maintenance window where your ECS task is going to be replaced and a new one's going to be spun up in its place, you want control over that. You don't want Amazon just to like, replace it at a time that's suitable for them. Could this type of like agent-based scenario be used for that type?
Yeah, absolutely, because you can have your agent integrate with your personal health dashboard, where usually apart from emails, you usually can see these information out there, and you can have an agent implemented out there that, you know what, this is my schedule window. that where you can go in and make changes to our system. And as soon as on the personal health dashboard, it has an information, you can of course configure an EventBridge, and then an EventBridge can go into this Lambda function of yours connected to Bedrock, and it can just put it up into another, in maybe in DynamoDB or somewhere, and it can, whenever is your scheduled window, it checks about it every hour, for example, and yeah, okay, it hits this scheduled window, it goes in, makes changes to your ECS, brings up the new services so that you're not bothered by AWS. So yeah, in theory, it is possible, but there's also a bit of a caveat around, being a little destructive in nature. So that is something that everyone has to make sure that if they are able to have that risk appetite for it.
And as I've said that idea on camera, I'll take 10%.
I'm sorry, we're going to have to cut that one short. I'm bored of listening to all the questions. Well done. Have a cookie. There's loads of them. So, obligatory filler slide. That's us again, if you didn't see it earlier. Paul can keep his microphone and just come up here, to be really honest, and bash on, because we don't have time for anything else, I think. Although he appears deep in conversation about something else. Yes, it is you. That's, main event. Yeah, they're on there. They should be on there.
Like, this is so professional.
That depends on your eyesight.
I can do it. It's fine. Okay. Hello, everyone. My name is Paul Stack. I am here to talk about using the Cloud Control API. Some of you may or may not know the Cloud Control API. Anybody does? Wonderful. This is going to be a journey. This is going to be a real journey. And so I work for a company called System Initiative. I am the director of product there. I am actually a techie. Okay, I'm not a real product person. I'm actually a technologist. Like, I've been doing infrastructure as code for a long time. Previous to this, I have been in the infrastructure as code space heavily. Okay, I was very early at HashiCorp working on Terraform, like back when it was Terraform 0.6, before you even had a helper schema. And I worked there until the whole way until that decision was made to split out all of the providers from one single binary, and you had to have different binaries for each provider. After that, I decided I didn't get kicked in the face enough in the infrastructure as code world, so I joined a smaller company called Pulumi, which was redesigning how infrastructure as code worked using modern programming languages and how they approach for there. Stayed there for a long time, loved it, and I sort of came to the idea that infrastructure as code is beginning to be broken. Okay, so since then, I've joined a new company called System Initiative that is trying to do infrastructure as code in a new way. Okay, and I'll explain a little about that in a little bit. You can find me on the internet. There's some links there, but that's not that important. Okay, so System Initiative, TLDR, we are trying to walk the tree back for infrastructure as code and look at where it started and what it was trying to design. So I give another talk about this, but ultimately all of the infrastructure as code tools right now are they're an evolution of each other. Okay, it all started with CF Engine back as a config management tool. Then it went to Puppet, Chef. Then it went into Ansible. It went into CloudFormation. Went to all these pieces, and it's continually like made progressions. It's desired state. Okay, desired state is sometimes difficult, especially like following on from Nelson's talk, where you have outside interference that happens and you have a desired state. And in infrastructure as code space, the code is the representation of what the truth is in your ecosystem. But we all know that that is actually not really the case, okay? Because we're developers and operations people, and if we need to take a shortcut here or there, we will. We absolutely will. Okay, and I can guarantee you we will, because if I went to my CTO and I said to my CTO, it's going to take me a week or 2 days or 3 days to make a change through my pipeline safely to be able to change this configuration, but I can go to the AWS console and change it in 5 minutes and then retrofit it, they will say, take that 5 minutes. Okay, any CTO in the world who values cost will do that. Okay, and now I've learned that because of being in product. And so we try to look at things in a different way, okay? So we're trying to build it in a digital twin, okay? Now, a digital twin's an interesting idea for infrastructure because you have a real world object and you have a virtual representation of that real world object, and then use data to simulate moving things either side. The best way to think about a digital twin is something like an airliner is a bad idea at this moment in time. Let's not talk about airlines because that's not going so well. Let's talk about Formula One cars, okay? Because Formula One cars, you can't just make a change to a Formula One car and put it on the track. It could have devastating effects on like your car. It could have dangerous effects. Now, I'm not saying if you change infrastructure as code, somebody's going to die. Please don't take that. That's what I'm saying. But it could have catastrophic effects for your infrastructure, for your application, for your users. So what we try and do things is we try and do this in a simulation-based approach. You can imagine that you have a head representation of what is in the real world, and then you create chain sets, which are each chain set is a simulation, and you can check and see if I change this variable, it will walk the graph up and down and tell you the effects and changes it's going to have. Because the real-time aspect for us is very important. It's not just what's in the infrastructure as code, it's actually how that interacts with the real world. So it's a real-time two-way sync to be able to help you determine what's going on. The interesting thing here is that we don't really want you to be constrained in a particular way. We actually believe that the digital twin model is really important. So therefore, our representation of a cloud asset is a one-to-one model. Okay. Now, I said I worked for Terraform. If you've had bugs with Terraform providers in AWS, I'm sorry. Okay, because I promise you, if you look at the GitHub contributions or the blame, I'm probably to blame for a bunch of those bugs. A lot of that code base was written super early on. The design of the API shape was basically whatever developer decided to build that asset there and then, or that resource there and then. And that's why you get into scenarios where like maybe 2 years ago, they had to completely destroy the S3 bucket object and it had to be split out into individual pieces because the design of the resource didn't really sort of represent what the real world outcome is. So we've learned a little from that, okay? And I mean, we've learned because of the fact that that's a very difficult model to say. Carl would design an API differently to what I would design based on like how he uses AWS. So we've tried to like set the playing field of a one-to-one model. Now, the challenge is that staying up to date with the cloud APIs is a nightmare. It is an absolute minefield because they move at such a pace. Now, I'm not saying that this is not about bugs or anything like that. This right here representation of the Terraform and Pulumi repos for AWS represents not only issues, but mostly feature requests and pull requests about new versions of APIs that have come out, new products that have come out, new pieces of like infrastructure that people want to take advantage of. Now, couple that with the diamond dependency problem of a version of Terraform has to relate to a version of a provider, and a version of a provider has a specific version of the code or the resource in it that you need, and it just becomes very difficult for us to actually do our jobs. These companies have been phenomenal doing this. Okay, this talk is not throwing shade on any of these companies doing it in any way, shape, or form. Absolutely not. HashiCorp are absolutely the leading name in infrastructure management. They've done incredible. They will continue to do incredible. Pulumi is a huge up and coming. You have other tools that are also starting to provide the way into the ecosystem as well. But I promise you, they're all facing a very similar problem. Cloud APIs are super difficult. Now, the issue is that we try to look at how would we take an approach of that? How would system initiative be able to handle it? We don't want to do the same thing that Terraform did. We don't want to manually create the APIs. We don't want to have like expect our community to come and bring the providers to us. We needed to look at an automated way to do it. Now, we did this in a number of ways to start with. We really did. First way we did it, we used the AWS CLI. This is even this slide right here, okay? The AWS CLI has a wonderful argument that you can pass into it called generate CLI skeleton. Okay, it pops you out a JSON blob of the arguments that you can pass into the CLI, and you can actually do that. We use that output to be able to generate the first version of System Initiative assets, and it was great. It worked really well. Somebody had to manually run the command to do it. Meh, that's not too bad. Then we were like, could we automate that? What version of the CLI? Because each version of a CLI is different as well. So it became a little difficult about how we actually did it. And we started looking at other ways to be able to handle this. Now, System Initiative, as I said, is this tool that allows you to do this two-way sync between yourself and the cloud. And it doesn't matter if under the hood it talks to the API, it talks to the CLI, it talks to 5 different APIs in the call. It doesn't matter. It is a representation of what you need it to do. So the first version of it actually talked to the AWS CLI. So it shelled out directly to the AWS CLI and built the JSON object that it needed to push in. And we were like, that's not a wonderful way of doing that. Let's look at a different way. So we started looking around, and I've known from my time at Pulumi that back in September 2021, Amazon released a new AWS API, and its name was the Cloud Control API. Now, it had a promise of it was going to be a unified set of APIs for CRUD actions. Okay. It was, it's their solution to reduce resource management fragmentation, because we all know, whether we like it or not, Amazon is a huge company. It's basically multiple companies come together. Each service is so different from each other that they don't have a similar API surface. So you see that in things like tags, because in each part of the AWS surface area, the tagging API can be incredibly different. Sometimes it doesn't even exist in some parts of the product because of the fact that each team sort of decides themselves what they actually need to do. So Amazon wanted to look at it. So what they actually said here is that this Cloud Control API was going to be an abstraction layer on top of each of the service APIs. Okay, very interesting concept. Now, its core capabilities, it had 5 APIs that it was going to have. It was going to have create resource, update resource, delete resource, list resource, and get resource. Okay. It was going to be an eventually consistent API. So you would dispatch an operation in the same way as you would dispatch an operation using CloudFormation, and you would be able to get a token that would allow you to be able to understand that request status, to understand whether it's progressing as expected. Now we know, I'm sure people have been caught before, when you deploy something like RDS or EKS, they are slow operations. And if you don't want them to run in the background, just be prepared to go and do something else when those clusters are actually deploying. So they wanted to be able to give you this request status to understand. But the interesting thing is they wanted to be able to give you was they wanted to be able to allow you to do discovery of what was out there. Okay. Now this for us at System Initiative was incredibly interesting, because we have this infrastructure tool where we can have all this data to be able to pull in, and being able to discover the data is very cool. I'll talk about that in a little bit. Now, what it actually allowed you to do was an API that looked very similar to this. Now, this API basically uses the CloudFormation specification. So canonical within AWS, there is a CloudFormation specification for every resource type. Okay. Now you'd be able to pass in that CloudFormation specification, and you would be able to pass in the service type that this actually managed. This right here is how to create a DynamoDB table using the Cloud Control API as shelled to the Amazon CLI, AWS CLI. Okay. Because the Cloud Control API can be done via the CLI, or you can talk directly to the AWS API or SDKs themselves. Now, the very cool thing here is that this would return a token, and you could run that request in the background. You could pull, you could back off, you could auto retry to understand the status, and be able to build this reactive system that you could dispatch an operation and be able to really allow your program to continue, or your work to continue, and then check back in on in the background. But one of the benefits here of adding another API layer, okay, because you have each service API layer, and now you have another API layer on top. Now, in the infrastructure as code world, we would call this the 200% problem. Okay, and I'll give you an example, please. Again, don't think I'm throwing shade. Terraform is a perfect example for this. you need to know the API surface of an individual resource in Terraform. Okay. And you also need to know that that API surface doesn't necessarily represent what is in the AWS CLI or the AWS API as well. So you need to go and find maybe the 3 resources that come together to make a service in AWS. So you need to have 100% of the knowledge of that resource, plus you have to have 100% of the knowledge of the service that you're actually interacting with, that you're trying to create. So we call it the 200% problem. So we're worried that this would be the same style scenario of having that 200% problem, but they promised us 5 things. Okay, they promised us consistency so that these same patterns would work across each service. That immediately to me was like, holy, I'm Northern Irish. Okay, if I swear, I apologize. I know it's on a live stream, but it may happen. It just comes out. I promise. It's like I don't mean it in any derogatory way, but at that point, consistency across each service was like, that's incredible because the services don't have consistency at this moment in time. Secondly, I only now need to learn one API because they made it work with the CloudFormation specification. That is the most documented specification inside AWS. In fact, you go to any Gen AI tool, ChatGPT, Claude, Bedrock, anything, and you ask it questions about the CloudFormation specification, it will give you the most perfect answer because it's so well documented. So therefore, I don't need to worry about that CloudFormation specification. I need to just learn how to interact with the Cloud Control API itself. They say it's future-proofed, okay? Each team within Amazon have opted in that they will actually add all of their new services, all of their new resources to Cloud Control because it is going to be the canonical way that they do it. In fact, under the hood, CloudFormation is going to start using this exact technology. Okay, they have a long pool of resources that they're doing right now, but this is exactly what CloudFormation is going to be able to do because of that token-based approach where it dispatches the operation, where if you look at the CloudFormation console in Amazon, it's like creating template, oh, it failed rolling back. So it's able to understand these operations. So it can future-proof it and they can use it. And then interestingly enough, because it's an API, it is program language agnostic. Doesn't matter. REST API, friends. Takes a JSON specification, it is well documented. You can generate any programming language that you want. It can be a DSL. You could have it in Ruby. You can have it in R if you want to show it at the Aero conference. There's a little look at that, always keeping the sponsors happy. And like it can be anything, honestly. And it's whatever works for you. And that's what Amazon wanted it to be. It wanted it to be meeting you where you actually work. And then lastly, it's automation friendly. It's declarative. Okay, because it's declarative, it allows automation. You can build a portal, you can build infrastructure as code, you can do whatever you want with it. So it's going to work, right? Well, okay, usually I would give a demo here, but we're not going to. So our attempt 1, no, it does. It works incredibly well. Well, I'll tell you, the first attempt did not work so well. Okay, now what we discovered is that in the 4 years since I used Cloud Control API, that they hadn't finished porting all of the services to the API. And because not all services were implemented, we were actually ending up creating assets in System Initiative, our resources in System Initiative, where when we generated this, we got 1,800 resources, right? That's how many resources, give or take, there are services in each part of a service within Amazon. And it basically was like, this is awesome. We went to our customers like, look, I've automated the entire of the AWS ecosystem. You can start using it. One of the first customers that started using it pulled on an obscure asset and it looked great and he ran it and it returned an error saying not supported in Cloud Control. And I was like, oh, Jesus. Because that was classed as a successful operation. But the message that it returned was basically a 204 saying, we've taken that request. It looks great, friend, but that's not a supported operation. So we can't do anything with it. So we had to look at it and we had to say, right, what is supported, what is not supported? And we found this little page on the Amazon website. And that page basically told us each service and how each service was implemented. Now, we couldn't find this documentation anywhere else. And it was very much a case of, what do we do in this case? What do we do in this scenario? Now, I feel this is a safe space, and I feel I could admit this. I wrote a HTML scraper, and I scraped that page, and we pulled out all of the stuff, and we tried to do that. And it was a little better. A little better. Okay, we found the correct incantation. We found that sometimes there were things supported in Amazon, some things that were not supported in the cloud control, but basically we were able to remove 500 assets that were not supported, okay? And 500 seems a lot. That's because of how we generate composable assets. So for example, if you're in a task definition can take a number of container definitions. Each container definition would be its own resource that you can build composability in our model, okay? So we lost, like, across the entire service area, we lost about 500 assets plus including the composables, which was okay, right? But we still had this idea now. We have things that work. We have things that don't work. What do we do about the things that don't work? How do we determine that they don't work? So we went back to the drawing board, and we tried to think of a number of different ways. We tried to use Gen AI to do this. Okay, disaster. Because if you haven't realized this yet, Gen AI will make shit up. It will decide what looks great and what fits your specification, and it will return it, and you'll not know the wiser until you test it. And it's like, that's not a supported argument. But yet, when you look at the spec that it generates, you're like, that actually looks like it should be an argument in there. And that's why Gen AI has come up with this idea that it should be in there, and it's not. So we built this internal dashboard within our organization where you could take any AWS CLI command, and then you would be able to bubble it up. So like AWS S3 bucket, and it would actually build all of the CRUD applications, and Gen AI just butchered it. It butchered it, right? It just gave us all sorts of rubbish in there. So we had to have a look at what we were actually doing. About this time, we found that in the cloud control or the CloudFormation specifications, there is a section at the bottom of the specifications called handler. Now, this is very interesting because when we cross-checked the handler section with that documentation page on Amazon, we could see if there was no entries, there would not be a handler section. If they had support for create and delete, there would be an entry for create and delete in the handlers, and there wouldn't be one for read, etc., etc. Eureka. We literally found the incantation that we actually needed to make this work. And what this actually did is this allowed us to be able to create the correct format of each asset. Because before, we removed the assets that didn't have support for for the Cloud Control API, but there were still specific like parts of the API that weren't supported. So for example, an AWS Route 53 record set, there is no get. There is a list, and then you can filter the list, but there is no specific get because a Route 53 record set does not have a unique identifier. Okay, the same thing happens with other parts of the system. An ACM certificate has no get in the AWS CLI. It has a list, and you pass the filter into the list, and it actually does the filtering internally. So some of the older services hadn't quite caught up yet, and this allowed us to be able to do it. But we still had one conundrum that we had to suffer, which was, what do we do with the 500 resources or the parts of the system that didn't have support for CloudFormation? Or excuse me, they didn't have support for the Cloud Control API. Now, we know they're supported with CloudFormation. So we had this idea, it's like, why can't we just have a CloudFormation resource and system initiative where you build your composable asset up, you model it together, and you pass that data into CloudFormation and just handle it in CloudFormation as part of what's going on. Worked incredibly well. Honestly, it still works today. We use it internally ourselves, and we do a lot with it. And it now allows us to be able to build these types of composable diagrams that pass data on. So you take an ACM certificate or a Route 53 record set, you take inputs into it, it would pass it on to a CloudFormation template, and then that CloudFormation template would pass it into a CloudFormation stack, and the CloudFormation stack would run the API command to do it. Now, there are still some issues, a lot of issues, because CloudFormation doesn't natively support import or discovery. Now, the Cloud Control API gives you gets and lists. If you create something in CloudFormation, you cannot import that back. There is no API to get it. You can go and you can find a unique identifier in the Amazon console, and you can use like a Terraform import command or a Pulumi import command, but there is no API to be able to get that resource back because it doesn't exist. We promised our customers, hey, you don't need to rewrite all your infrastructure. You can just import your existing infrastructure in the system initiative, because why would you spend the time to convert from one IAC tool to another? It doesn't give you any value. This is the value that it provides to be able to go and discover your infrastructure under the hood. But then, of course, I can't support that for some of the arguments and some of the operations. So it's a bit of a difficult scenario that we're still having to figure out here. Also, some of the Cloud Control API requests don't return all of the data that you need. Launch template is a perfect example. If you ask for a GET request to a CloudFormation or an EC2 launch template, and you pass in the launch template ID, it returns you the version. That's it. And then you got to make another request to go and get the information for that specific version. Now, in a model like ours, that two-step operation just doesn't make sense for a user, because a user doesn't need to know the version. It should happen automatically based on what is marked as the default or what is marked as the latest, depending on how they use it. So we needed to be able to override this information to be able to pass in data that's there. So we built this override system where you could effectively override any part of the API surface to be able to go and use a different part of the API. Launch template is a perfect example. We know Cloud Control doesn't give us the data that we need, but we know based on a launch template, I can shell out to the AWS CLI and it gives me everything I need. So for that particular operation, rather than talking to the Cloud Control API directly, I use the AWS CLI. So it's the mix and match to be able to get you all of the information that you need. Second thing that we wanted to be able to do here, we are not a desired state tool. Okay, so you don't just say, give me 3 instances and those instances are running. You would say, give me 3 instances and make these 10 commands that sit on top of them, right? Similar to how people would use the remote exec or null provisioner in Terraform to be able to do that based on your product. But we have native support built in for it. So for example, our workflow would allow you to be able to say, make a change to this RDS instance, but before you do that, take a snapshot, restore that snapshot onto another database to make sure that you have a backup available that you can quickly swap back and across to, and then be able to proceed with the operation. You can build these complex workflows. So being able to build and override those specific scenarios were incredibly easy for us, because we could do an EC2 instance is a perfect example. For the EC2 instance, you would shell out to AWS Cloud Control API for the create, the read, update, and delete. But when you have to take action on the instance itself, terminate, start, stop, reboot, all like change user data, do these different things, you could actually use the AWS CLI to be able to take care of it. So it was like a very interesting mix and match here. I would usually give an overrides demo, but I can't. I'll show people at the end. Now, there's got to be a way that we could have done this better with GenAI. Okay, GenAI sort of didn't really, it wasn't fruitful for what we were actually doing in the first time around with the AWS CLI. Maybe there is a new way going forward that we can take advantage of GenAI and the CloudFormation specifications to be able to do it. The worry is its unpredictability on being able to give you that temperature. Like, even though you can specify into ChatGPT, I want the temperature as close to 0 as possible, it's still going to make shit up. Right? It's because it's the type of tool it is. It's never going to give you that 100% answer, because that's not what it's designed to do. So maybe there is actually things there. But for us, there's a pipeline. more importantly, we built this pipeline that every single night we actually get new updates from the AWS Cloud Control API. So our assets are as fresh, up to date as you could possibly get, as possibly see. You can, everything I'm talking about here, by the way, is open source. So you can go to the repository. You can see the API requests that come in nightly. We can see a full diff of what changes, even documentation changes. Now, we went a little further here with our documentation changes because sometimes in the AWS world, the documentation is very good and sometimes it is not, okay? Sometimes, for example, you have enum values that are available and they make that in the description or they make them enums in the CLI itself or in the API itself. So we actually took the documentation and we fed that into GenAI. And to be able to get a canonical set of enhanced documentation that we could then present to a user, that was incredibly successful for us based on that AI story. That is where it excels, being able to take the data that you need to give it and manipulate that data in a correct response rather than try and work out what that data needs to be. So for us, nightly cron is our assets are only ever a maximum of 24 hours behind. That means that when you come in the morning and use System Initiative, you will literally have a little button on there and you says, I want to upgrade that specific asset type. It does it in a change set so you can see the effect that it has. You can see new props. But what that also does, because you can do that in a change set, we're a full fidelity tool that you can click a little beaker icon at the top and you can go in and edit that code yourself. Now, that is incredibly useful when you are an AWS insider or when you're like spend an absolute fortune in AWS and you get access to different tools, different regions, different pieces. Being able to go in and manipulate that data yourself is incredibly important. Our conclusions, the AWS Cloud Control API has mostly all of the data we need to make good decisions on our asset. And I say mostly because it is a work in progress. Where it was when I started using this, like I managed the team at Pulumi that built the AWS native provider at Pulumi. And where it was 4 years ago when I left Pulumi, it is light years ahead now, honestly. I believe there's something in the region of 70 to 75% coverage of the whole API structure, which is incredible, okay? Trust me, 4 years ago, they were not there. They have a plan. They know the roadmap of where they need to go for having everything else, and they're migrating it slowly. And we do see new assets that are covered every night that change from CloudFormation back to Cloud Control API. We could definitely leverage CloudFormation specs to generate a schema. That's going to enable us to have all sorts of goodies within our application. There is 100% AI features that will come to our app that will allow a user to be able to converse with the system that says, build me a task definition that uses this image. It needs to be in this operating system. And of course, it's CloudFormation. It will understand exactly what to do there. The missing discovery and import for assets for us at System Initiative is incredibly, incredibly painful when it is a non-supported resource, especially for some of the high priority resources. Record set, Route 53 record set is the highest priority thing that, as you can imagine, because to not be able to like import your existing Route 53 records that you can pass those into ACM certificates or you can pass them into CloudFront origins or whatever is just tough. It's a really tough way of being able to do it. And then lastly, being able to override any of the assets to be able to delegate out to the CLI, the API, to fuel it with extra information was so useful for us that our customers were able to take advantage of it straight away. Now, thank you so much. I would usually like show a bunch of demos in here, but as this machine's there, if you're interested in seeing how the actual code that comes together for this, I can happily show you. It's in TypeScript, okay? The reason, everyone's like, why TypeScript, okay? Everybody in the world who is in programming knows enough JavaScript to be dangerous. That is our philosophy, okay? It is a non-white space sensitive language, so you get great compile linting and you get great warnings about what's happening. If it was Python, it would be a bit more difficult as a barrier entry for some people. So we made it like we tried to lower the barrier to entry for people to be able to go in and use this and override and be able to see it. But I will happily take you through anything that you absolutely need to see. And I'm like, thank you so much for having me. I really enjoyed it. So. Any questions? The answer is no. Nobody ever has questions about Cloud Control API. Oh,
Well,
go on.
SRE in the room's got a question.
yeah, so where do you keep your state?
State is not a thing.
No, I heard you, but how do I know what resources I have and what deviated?
Great question. Okay, so question is, where do we keep state? I'll explain the differences between state and system initiative and state and Terraform, okay? Because I think that'll help a little bit.
Yep.
Because Terraform is a graph-based operation, you need to know what is there compared to what's in the system, right? It is a push operation. Terraform is a push operation. System initiative is a push-pull operation. So therefore, the only things state that we need to keep is our resource identifiers, right? So a VPC ID is the state that you keep. That is literally it. And anytime you go to interact with that VPC, the first thing it does, or anything that touches it in and out, the first thing it does is it goes off and says, get me the latest. Keep me up to date. Get me everything that's there, because if somebody's using it or needs to interact with it, it needs to be as real time as it possibly can be. And it's actually able to react based on that. So our state is only resource IDs, nothing else. Okay, so we don't keep like the block of all of the other parameters that go with it there, not important for us. What is important for us is actually what's in the real world. And because it's a digital twin, there's the component representation on the graph, and there is the real world object. The real world object is what's the most important thing. And then the simulations, every time you make a change, it goes, you've changed this particular ID. Let's go and see how that actually affects what it would do in the real world, or what it would actually do across the graph. So you can actually see the graph light up. If I change this ID, what is effects the whole way down through the system?
I might have to see it. So on a subnet, for example, how do I enable public IP? I want to.
So there's we will have a little card which has the attributes. The attributes will be fed based on what's currently in AWS. And if you need to change it, it will actually do it in a chain set. It will show you this is what you want to do, and it will allow you to merge that out whenever you want to, and it'll go and talk to the AWS API.
I don't see how that's different from Terraform. Yeah.
Sure. I mean,
because Terraform does the same thing, right? I mean,
No.
I have a state file,
Yeah.
and it goes to AWS, and it shows you, I don't know, on the stay on the subnet.
Terraform. Sorry. Okay. That's the difference. Terraform doesn't update your code when you refresh from AWS. Terraform updates your resource block. Then you got to update the actual Terraform representation.
Yeah.
We don't. There's no difference between our representation in the real world and there. What is in the real world is what's fed back into the UI that you can actually see. So if you change it in AWS, that's what comes back down into our tool.
Oh God, but I don't want that.
Why do you not want that?
And nobody should ever click.
But people do.
But they shouldn't.
I totally agree with you. They should not, but people do, regardless of whether we think they should not or they do. Companies do click. There are hundreds of companies that actually have a difference of people who are very sophisticated with their infrastructure as code, and other parts of the organization will just go in and click around like absolute yahoos and be able to do stuff because it's faster for them to do. And then what they do, they delegate that to the platform engineering team or the infrastructure DevOps team to be able to clean that up later. And it happens all over.
So you're trying to solve the clean it up later problem.
Yeah, we're trying to do it in different ways. We're trying to do it based on one, that you can understand that you can change things in different ways. You can do it via the CLI, you can do it via the console, you can do it via infrastructure as code, you can do it via Terraform. Like you can have a team using Terraform and still use system initiative because of how the data flows into Amazon. It still comes back into us anyway. It doesn't matter to us. So our source of truth is the cloud provider. It is not what tool feeds into it.
Yeah, I gotcha. Okay.
And because of that, that's why when we put this in front of some of the bigger companies, they're like, okay, so we have this team is outsourced that are doing this and they love Terraform, but we have this other team who are not very good. They want to do it in the AWS console. This tool brings both of those pieces together for your enterprise architects, and they can see what's going on at any moment in time. And now immediately they're like, we like that. We like that single pane of glass. We like being able to bring all that data back into us. So it's important for them to be able to do that.
So you said there's no import, but that means you probably have some sort of tool that scans an account and can import.
Yes. Yeah, that's exactly it. It's exactly it. So, and you can import.
And you're doing a bunch of gets and lists on Cloud Control API.
No, so it depends on what it is. If it's supported by Cloud Control API, then yes. If it's not, then we actually use AWS CLI to be able to get it.
How long does it take you to scan an account?
Oh, well, it depends what's changed. So, and depends on the amount of data in the account. It depends across how many regions. There's a bunch of factors, like how many services.
But you have to, yeah, that's what I was trying to say. Right. So I want to import an account.
Yep.
And it has, oh God, everything. It has
so
RDSs, open
could be
searches,
a couple of
EC2s.
hours maximum to bring in that first set of data.
Yeah.
Once it's all in, then it's much more easy to be able to keep on top of. But that first bulk import is the difficult part. And then it's able to actually detect if things have changed or not.
Gotcha. And do you run on AWS?
We do. We do.
Manage yourself with yourself?
We do. And we did an incredible thing. We actually built our own a firecracker execution engine. So all of the functions that run, we actually, instead of like shelling out to Lambda, because we know that people want to be able to run that trust barrier in their own AWS account, because we're SaaS, right? But they're like, hold on a minute, you're a SaaS. We don't want to give you your credentials. We want to be able to run those functions in our account. We're like, great. Here's our function execution engine. Yeah. It's one instance. It's like the way we've done it is like an i3 metal. It's chopped up into 50,000 firecracker VMs, and it's a warm pool on it. So each execution runs in less than like 2 seconds. So it's a maximum operation of like, it's just continually running functions. As soon as a function is run, the firecracker VM that it's running in has been destroyed and a new one brought up in its place, because we do not like leaving like state behind in functions, because that's when you can leak secrets. That's when you can leak state. That's when you can leak all sorts of things. And we just, I can say just yesterday, we got our SOC 2 type 2 verification based on like that type of stuff, because that is really important for our customers.
Gotcha. Yeah, demo would be great.
I can show you. It's cool.
So if we're going to do a demo on your laptop, it means we're going to lose.
Yeah, it's fine.
It's fine. But maybe the demo is only for the people who are in the room. So it's worth the. Yeah.
Any other questions from anybody else? Because if we want to do demos, then we'll wrap this lot up for the sake of the stream. Is that way Steve and yours are happier, because you need this for that.
Exactly.
And then we can do that. Not for the sake of that. It's too much like aggravation. Not to the live stream. So we'll wrap this up and then it's too much like hard work. And I'm sure if you pay him in, I don't know, alcohol, probably, he might do some recordings for you. You never know.
There's a bunch of recordings. There's a bunch.
Cool. So, thank you, Paul. Obligatory filler slide. That was what you've just been paying attention to, sort of, hopefully. Next event. So, we're not massively well prepped for this one. We were very well prepped for this one, not brilliantly well prepped for the next one. We're going to do October 29th here again, because we like it here. We're looking at doing a workshop, and it's probably going to be a pick from 2, pick from 3 at kind of a 100, 200 level. Bring your own laptops. We'll vend some accounts, and you can go and spend some Amazon credits, because we'll ask very nicely, and they should give us some fake money. So if you've got anything you particularly want to do, I didn't put a link to it. That's the link to the meetup event, but drop me a note on LinkedIn or Meetup or whatever. And if there's a particular workshop you want to do, let me know. I'll go and have a quick look at it, see if it's going to be too much like hard work to do pre-setup and stuff for, because I will try and preset some accounts and bits and pieces up. That's the idea for the next one. But yeah, you do need your own laptop. Please do bring your own. You won't be able to do it on a phone. You might be able to do it on a Chromebook, but probably not. Bring an actual laptop. Finn, done. Thank you very much. Bye to the